Number 26 uses this property of logarithmic equality. What the rule says, and just like, I guess ignore all this right here. If you have an equation with something on either side, you are allowed to log both sides with whatever base you want. And typically when we solve a problem, we'll log with base 10 because we have that base 10 on our calculator. So if you look at the rule, it says log base a of m. That just means that a is any base that you want it to be. And again, we usually pick 10 for base a. And then log base a of n would be on the other side, and you would just make sure you match the bases on both sides. Now you can go in reverse. If you have a log equal to a log, you can work in reverse and actually remove the log with the same base from both sides and drop down just what you're logging. And that's what you do in number 26. So it can work both ways, this property right here. So I'll show you the property used the way it's shown here, where you start with something that you end up logging on both sides. So I have 3 to the x equals 20, and I'm going to actually log both sides, and I'm going to use base 10. And normally we don't write the base 10 down, but I'll just write it in there so you can see it. And the reason that I chose base 10 to solve this problem is because that's on my calculator and I have that button on my calculator to use. And by logging both sides, it's going to allow me to drop down that exponent out front. And then I can go ahead and solve for x. I'm actually multiplying x by log base 10 of 3. So the opposite of multiplication is division, and I can divide off that log. What I do to one side, I do to the other, and then it's ready to go in my calculator. I just punch or type that into my calculator and figure out the decimal answer. So I don't know what it is, but I don't feel like getting out a calculator to do it, but you would do log of 20 divided by log of 3 in your calculator, and you don't even need that base 10. You don't like type that in, you just type in log 20 divided by log 3. Now we're going to use in number 26, instead of putting the log onto each side, we're actually going to be taking it off. Okay, so there's 26. Before I can do that, before I can take the log off, I actually have to condense my 2 logs into one first. So I'm going to take my subtraction and I'm going to turn it into a quotient. So I have log base 8 of x minus 1 over 5 is equal to log base 8 of 34. And now we have our logarithmic property of equality. Not only can you put a log on both sides with whichever base you want, but you can remove the log as well. So now we're really starting with the property. We have log of a to the m is equal to log of a to the n. You have a log on both sides with the same base, and you can just drop that log off and set whatever's left equal to each other, and that's what we're going to do. Log base 8 on both sides, I get to drop it, and then I'm going to go ahead and bring down the rest of the problem. And then I just multiply both sides by 5 to solve. If it helps you to put this into a proportion, then you can do that as well. You get x minus 1 times 1 equals equal to 5 times 34, and then that's 150 and another 20, That's 170. So you get x minus 1 is equal to 170. And then add 1 to both sides, you get x is equal to 171. So if you can condense your equation, condense your logs, and you get a log equal to a log with the same base, you just get to completely remove it. It's the logarithmic property of equality that lets you do that. You can either log both sides of an equation, or as long as the base match, you can remove the log from either side of the equation as well.